Good morning and welcome to all of you who are just now joining our broadcast of the ITER Start of Assembly ceremony. We have just concluded the worksite tour and are beginning to start the formal ceremony. For that purpose, I would like to turn to the man who has been leading this project with remarkable intensity and dedication for the past 5 years and a little more. Please welcome Dr. Bernard Bigot, the ITER Director General.
Thank you very much, Leban. Welcome to all of you who are joining us. Those who are physically present here with me in the ITER Assembly Hall. Those of you with me here on the stage, representing the 7 ITER members, and those of you joining us virtually from all around the world. Above all, on behalf of the global ITER community, let me express my thanks to the President of France and the other heads of state and ministers representing ITER members who are joining this celebration remotely. We together, with the ITER Council Chair, Monsieur Liu De Long, are deeply honored by your presence and participation. It illustrates the importance of what we are celebrating, the start of machine assembly at ITER. Today is an historical moment. Fusion energy is a gift of God's. It is because of hydrogen fusion that we are all alive today. Without fusion taking place in the sun, we would not have no light or warmth. This would be no life on Earth. The concept of recreating that incredible energy sources here on Earth is a typical human approach to take the best of nature. We try to understand nature, and then we try, with human imagination, to recreate what nature shows us. But nothing is typical about the ITER project. It is a first-of-a-kind machine, made up of many first-of-a-kind components and breakthrough invention. To build this machine, a star on Earth requires a level of international collaboration that is also first-of-a-kind. When I think about the significance of this point in ITER history, as we launch machine assembly phase, 3 points come to my mind. First, we feel the weight of history. It is now 100 years ago since scientists first understood that fusion energy was a power source for the sun and stars. It is more than 60 years since the first tokamak was built in Soviet Union. In that context, when we consider we have a little more than 5 years to go before ITER's first plasma, it does not seem so long. Whatever we accomplish here at ITER, clearly we are building on the scientific discovery and technological innovation of decades of researchers and inventors. We could not be here if we were not standing on their shoulders. Let us thank them and pay tribute to their works and wisdom. This machine will offer to their successors a unique opportunity to understand for the first time the behavior of an ultra-hot, ultra-low density burning plasma they have been dreaming about. Second, we feel the need for both urgency and patience. We know we need a replacement for fossil fuels as soon as possible. We understand very clearly the promise of fusion power as a safe, reliable, environmentally sustainable, and virtually unlimited source of energy. If fusion power becomes universal in complement to renewable energies, the use of electricity could be expanded greatly to reduce the greenhouse gas emissions from transportation, building, and industry, enabling the exclusive use of clean energy will be a miracle for our planet. But building a fusion power plant is not easy. We are moving forward as rapidly as possible, but in order to succeed, we must also be deliberate. Quality and safety have always to be first. If we succeed, it will be worth all the time and efforts that have brought us to this point. Thirdly, we feel a deep sense of gratitude for the enduring support of ITER members. We are grateful to the government that provides us with funding and direction. We are grateful to the 10,000 workers at every level in every ITER member countries. We are committed to making ITER succeed. We could not do this alone. With your help, we have completed about 70% of the total construction work leading to first plasma. Today, as we look forward to the machine assembly phase, we know that the hardest part lies ahead. Constructing the machine piece by piece will be like assembling a giant three-dimensional puzzle on an intricate timeline. Every aspect of project management, system engineering, risk management and logistics of the machine assembly must perform together with the precision of a Swiss watch. We have a complicated script to follow over the next few years, definitively. We understand the need of humanity for clean energy. Our goal is to leave a better energy future for our children and future generations. So we move forward with a deep sense of purpose, with gratitude for this historic opportunity. We cannot afford to fail. It is now my pleasure to introduce Monsieur Liu De Long. Monsieur De Long has been one of the leaders of the ITER project for many years, leading the Chinese domestic agencies, as well as representing China in the ITER Council. He is the current chair of the ITER Council. I give the floor to Monsieur Liu De Long.
Thank you, Director General Bigot. Good morning to everybody. On behalf of all the members of ITER Council, I would like to repeat and echo the sincere welcome you have already extended to all our guests. I would especially welcome, with a deep sense of humility, our host, President Macron of the French Republic, President Xi Jinping of the People's Republic of China, my own country, and the other heads of state and senior ministers, extending congratulations to this celebration. Your presence, in one way or the other, is a testimony to the historic importance of this occasion. I'm really sorry not to be able to be there in person, but it's a privilege to participate in this remarkable event. The COVID-19 pandemic has made all of us learn to operate differently, often at a distance. Last month, the ITER Council met virtually for the first time in its history. Being at a distance, however, has not made us care any less about the ITER project, nor has it reduced our sense of pride and sometimes amazement. As we see the outstanding progress that has been made over the past 6 months, with the pandemic impacting so many aspects of our lives. This challenging time has coincided with a critical period in the ITER schedule. I'm referring to the completion, transport, and arrival at the ITER site of the most important first-of-a-kind components. Some of these components have been worked on for over 5 years, or even more than 10 years. They weigh hundreds of tons, requiring special shipping conditions across oceans, over special railways, and using unique vehicles. When the pandemic hit, the ITER Council watched with pride as the ITER community came together to develop a prioritized continuity plan. That plan has been carried out with precision in every detail. As with countries around the world, France has suffered during this pandemic. And yet, remarkably, there has not been a single COVID-19 infection on the ITER worksite. It is what Director General Bernard Bigot has come to call the ITER miracle. On behalf of the ITER Council, I congratulate Dr. Bigot for his unwavering leadership during this difficult period. And I salute the entire ITER community, every member, every domestic agency, every supplier company or contractor, and every staff member for their dedication, perseverance, commitment, and hard work. If we are able to continue in this way through the machine assembly phase on which we embark today, I have great confidence that we will succeed. Thank you.
Thank you very much, Chairman De Long. Your support is highly appreciated. Today is a very special day for ITER and for all ITER members. After many years of preparation and a lot of efforts everywhere in the world, we are ready to celebrate the start of the tokamak assembly phase. Indeed, we are now able to launch this new phase in parallel with the design and manufacturing phases because we have received recently, as planned 5 years ago, all the first components from the ITER members we needed to proceed. The tokamak building and the assembling hall from Europe, the 3 large pre-assembled parts of the cryostat from India, the first sectors of the vacuum vessel from Korea with parts from India and Russia, the thermal shield from Korea, and the 2 first toroidal field coil from Japan. Furthermore, the many other components that will complement this first step are all on their way to be delivered through 2022, including the feeders from China and the central solenoid from the US. In 2006, in Paris, the 7 ITER members decided to locate the project in Europe, more precisely in Provence, France. Since then, France, as the host state, has provided the best support to ITER and has fully complied with its commitment. It is highly appreciated by all ITER members. During the last 3 years, President Macron has always been very supportive of ITER and helpful to overcome any major difficulty we may face. We are very grateful for your always timely and decision action when ITER calls upon you, President Macron, to help, including for your participation today. So it is my large and sincere pleasure and honor to give you the floor, Mr. President, from Élysée Palace in Paris, which is precisely where the ITER agreement was signed 14 years ago on 21 November 2006. Mr. President, we are listening to your introductory speech before we listen to the high dignitaries from all of the ITER members, and we would like to warmly thank them as well for their participation and continued strong support.
Il est des moments où les peuples, les pays du monde choisissent de dépasser leurs différences pour se hisser à la hauteur de l'histoire. Et le lancement, au milieu des années 2000, du projet ITER est de cela. ITER, c'est une promesse de paix. Les États-Unis, la Russie, la Chine, le Japon, l'Europe, l'Inde et la Corée mettant à disposition leurs plus grands scientifiques, leur meilleur savoir-faire pour le bien commun. C'est la preuve que ce qui rassemble les hommes et les États est plus fort que ce qui les divise. ITER, c'est une promesse de progrès, de confiance dans la science. Et c'est d'ores et déjà une prouesse scientifique et technologique. Imaginez que l'expérience soit concluante, qu'elle puisse trouver demain des applications industrielles. Nous aurons mis au point là une énergie non polluante, décarbonée, sûre et pratiquement sans déchets, qui permettra tout à la fois de répondre aux besoins de toutes les zones du globe, de relever le défi climatique et de préserver les ressources naturelles. Avec la fusion, le nucléaire peut être une filière d'avenir, encore plus qu'il ne l'est déjà. ITER, c'est précisément un acte de confiance en l'avenir. Les plus grandes avancées de l'histoire ont toujours été des paris, des parcours semés d'embûches. Au départ, on pense toujours que les obstacles seront plus forts que la volonté de faire, d'avancer, et ITER renoue avec cet esprit de découverte, d'ambition. Avec cette idée que grâce à la science, demain, en effet, peut être meilleur qu'hier. C'est pourquoi je suis fier que notre pays accueille ce projet pour l'avenir de l'humanité. ITER en latin signifie le chemin. La France, dans une Europe forte, entend à nouveau être de ces forces qui tracent pour le monde un nouveau chemin, un chemin de prospérité, un chemin de progrès pour tous. Merci à vous.
Clearly, we owe a big thank you to President Macron. We are now going to turn to a short video for you, which will recall the contributions of the 7 ITER members that is making this transition possible at ITER, and it will explain a bit about machine assembly.
ITER, the world's largest tokamak, will demonstrate the scientific and technical feasibility of fusion power. 30 meters in diameter and nearly as many in height, the ITER tokamak is a marvel of engineering, created from an estimated 1 million components. The size and weight of the major components, the tiny tolerances for the assembly of major systems, the diversity of manufacturers, the tight schedule, all of these elements combine to make ITER an engineering and logistics challenge of enormous proportions. It was in November 2006 when the 7 ITER partners gave the starting signal for one of the largest international scientific endeavors ever attempted. Soon after, diggers and scrapers moved in to prepare the 180-hectare stage. And here we are today, 14 years into realization, celebrating the official start of machine assembly. Despite the challenges of the COVID-19 pandemic, we have managed to maintain critical activities on the worksite, including the reception of a number of ITER's exceptional first-of-a-kind components. In March, the European domestic agency, Fusion for Energy, put the finishing touches on ITER's assembly theatre. A vast hall for preparing, then installing machine components. In April, the first 2 toroidal field coils, superconducting magnets weighing 360 tons each, arrived from Italy and Japan. In May, the 1,250-ton cryostat base, supplied by India, was successfully positioned in the tokamak pit. Late June, the first ring-shaped poloidal field coil procured by Europe arrived from its manufacturing site in Hefei, China. Russia and the United States are also progressing in the procurement of critical path components for ITER. Finally, the first sector of the ITER vacuum vessel shipped by South Korea has arrived on French soil and will soon be transported along the ITER itinerary to the worksite. The buildings and infrastructure needed for first plasma are 75% complete, and the pace on planet ITER is picking up as machine and plant components arrive from the 7 ITER members. The time has come to put the world's largest puzzle together, the assembly of the ITER machine. Following the spectacular lowering of the cryostat base, the further assembly of the ITER tokamak will proceed in a bottom-up fashion. Machine installation will continue with the lower cryostat components, the lower thermal shields, and the temporary support structures for colloidal field coil number 6. A set of spare pre-compression rings are the next in line, followed by the central support structure and the 18 gravity supports for ITER's huge toroidal field coils. Thermal shields that will help protect the superconducting coils are attached, and finally, colloidal field coil number 6 is lowered into the pit, followed by colloidal field coil number 5. In order to prepare for the arrival of the pre-assembled vessel sectors, an inner support column, a work floor, and 7 radial beams are put in place to stabilize the structure during assembly and welding. While the lower cryostat components are being assembled and welded in the tokamak pit, 2 giants are standing in wait in the adjacent assembly hall. Standing 6 stories high, the purpose-built sub-assembly tools will suspend each of the 9 sectors of the vacuum vessel in turn, while thermal shield panels and toroidal field coils are rotated into position. By the end of this year, the first completed sub-assembly will be transferred to the tokamak pit. 8 others will follow. Last in line is the 18-meter tall central solenoid. The powerful electromagnet will be the last major component to be installed in the machine pit before the cryostat is closed up. In all, dozens of custom tools will be required to assemble, lift, and finally maneuver ITER's super-sized components. The tools will have a range of lift capacities: 500 tons for the upending tool that will turn vacuum vessel components from horizontal to vertical, and 1,500 tons for the heavy lift cranes that will carry all major tokamak components into the tokamak pit for assembly and welding. The precise alignment of ITER's largest and heaviest components to within tolerances of 2 to 3 millimeters is essential to the successful operation of the machine. Assembly sequences have been planned with this in mind and will utilize sophisticated optical metrology techniques at each step of the assembly process. The closure of the cryostat by late 2024 will mark the end of the first assembly phase. The ITER machine will undergo 1 year of integrated commissioning and testing, culminating in first plasma at the end of 2025. Beyond its symbolic importance, ITER's first plasma will be an important trial run for the machine, a first occasion to verify the correct alignment of the machine's magnetic fields and the correct functioning of key systems. The very first low-power hydrogen plasma, lasting only a few milliseconds, will be followed by other shots of increasing power and duration. This shakedown mode, lasting a few months, will be followed by a shutdown phase, during which key systems for hydrogen and helium plasmas at nominal power are installed inside the vessel, such as the blanket, the diverter, and in-vessel coils. These components will be introduced through dedicated port cells in the vacuum vessel, requiring a whole host of custom-made tools, work platforms, and cranes. The world will be watching as decades of planning come to fruition, and the ITER tokamak is assembled from components shipped from all around the world by the 7 ITER members. ITER, leading the way toward
Thank you very much to the ITER assembly team that helped us a great deal in getting that video exactly right. We now turn to the global tour, where we will hear from each of the 7 ITER members. First, speaking on behalf of the host member, European Commission President Ursula von der Leyen was hoping to be with us today, but unfortunately was unable to do so due to unforeseen circumstances. Therefore, speaking for the European Union, we will turn first to Michael Meister, the State Parliamentary Secretary for Germany, and he will be speaking on behalf of Chancellor Angela Merkel for Germany's presidency of the Council of the European Union.
Director General Bigot, Your Excellencies, esteemed staff of the ITER organization, distinguished guests. It's a great pleasure to speak to you today as a representative of the Federal Republic of Germany. May I convey warmest regards and well wishes from Federal Chancellor Merkel and from Federal Research Minister Karliczek. It is a pity that I'm unable to attend today in person and have a look to the progress made at the ITER building site. But the pictures and the videos that I have seen on the ITER website are clear proof of the amazing progress made. Buildings and facilities, which were still in the very early stage of construction during my visit at the beginning of the last year, have since developed into splendid structures. This is particularly true of the tokamak complex. A year ago, I guessed into the huge pit where the machine was to be built. The recent installation of the heaviest component of the ITER, the 1,250-ton base section of the cryostat, and now the assembly of the tokamak means one huge piece of the puzzle will be followed by the next. It marks the start of assembly of the ITER machine. The ITER project has reached a critical milestone, and this is an occasion which deserves to be celebrated. Please allow me to take this opportunity to congratulate the entire team of the ITER organization and you, Mr. Bigot, in particular, for this latest achievement in the construction of ITER. The ITER project involves 7 partners. Besides the European Union, they are China, India, Japan, Russia, South Korea, and the United States. This fact makes one thing clear. Without the contributions made by each individual ITER partner, we would not have reached the milestone we are celebrating today. And that is why my congratulations also go to all the ITER partners. I am well aware that the entire team of the ITER organization is facing enormous challenges due to the COVID-19 pandemic. Work steps planned have to be rethought. Staff absence have to be compensated. Restrictions on imports and specific circumstances of the respective ITER members are complicating the timely delivery of components. The fact that the construction work is continuing despite these hurdles and that measures to minimize risks are being carried out at full speed shows that the project is in good hands. We are living in an age in which the search for alternative, sustainable sources of energy is of vital importance for the global climate. Solar energy and wind power are sources which we have already tapped with success. The increasing demand for energy worldwide means we must investigate a broad range of options to secure future energy supply. Fusion research makes a contribution to long-term application-oriented basic research. Fusion is a focus of Germany energy research. The outstanding scientific know-how available in fusion research puts a global responsibility on Germany to advance the understanding of fusion processes for energy generation purposes. This is why Germany is supporting the completion of ITER according to the planned time and cost schedule. Germany will also continue to secure adequate funding for the ITER project during its EU Council presidency. Because ITER is an international project, it poses challenges which we can only solve by taking action together. After the stage win, which we are celebrating today, we are very much looking forward to the next big milestone, the first plasma. Until then, we will continue to cooperate with Fusion for Energy to ensure that the European in-kind contributions are made on time and that our financial obligations are met. I wish the entire team of ITER organization all the best and great success. And above all, please stay healthy.
Thank you very much to State Secretary Meister as well as to Chancellor Merkel. We now give the floor to the European Commissioner for Energy, Kadri Simpson.
Presidents, Prime Ministers, Ministers, Director General, distinguished guests, greetings. I'm very happy to be speaking to you all from Brussels. I'm sorry I cannot be there in person today, but I'm looking forward to visiting the site as soon as possible and seeing your great achievement firsthand. Today, we mark an important milestone for the ITER project and for fusion energy development. 10 years of work and 10 million components will culminate in the world's largest fusion research device. We cannot understate the importance of this as a technical achievement. Almost every individual element of ITER is at the cutting edge of its field. And I'm looking forward to seeing these extraordinary components combined to make something even greater than the sum of its parts. But today we celebrate more than just a technical milestone. I would like to highlight 3 things in particular. First, the strength of international collaboration. This work has benefited from the global collaboration between the ITER members. And I want to thank our partners from China, India, Japan, Korea, Russia, and the United States for making this journey with the European Union. Without your participation and contribution, we would not be here today. I would also like to thank the European Domestic Agency and Fusion for Energy, as well as all the European companies and research organizations. Each of you have worked tirelessly to deliver the European contribution to the ITER project. Reaching today's milestone would not have been possible without all parties working towards a common goal. Second, ITER represents the determination of the EU in the fight against climate change. This Commission has adopted the European Green Deal as its roadmap to climate neutrality by 2050. In that light, the clean energy transition is both an ethical necessity and an economic opportunity. ITER perfectly demonstrates this duality. It is a major investment in our high-tech industries and clean energy sources for the future. Finally, I would like to talk about the importance of continuing to support projects like these in challenging times. The COVID-19 pandemic has forced us all to readjust our priorities. Europe is no exception. The European Commission has revised its proposal for its long-term budget and proposed the Next Generation EU to tackle our recovery. The journey might change, but our end goal remains the same, and so our commitment to projects like ITER cannot waver. It is not only a milestone on the path to fusion power, but also a valuable tool for investment and development of our industries. This is why the European Union will maintain its support to ITER over the next 7 years. To finish, I want to thank all of you for your strong willingness to make a success of ITER, and what a success it has become. I also want to give special thanks to the representative of industry and the research community assembled. We have learned so much from you. You are the beating heart of ITER, and its success depends on your vision, creativity, and hard work. Of course, challenges still lie ahead of us. From this point on, our work becomes even more delicate and complex. But month after month, as a result of your work, plans are becoming reality, and fusion research will soon lead to fusion energy. We are on the right track, so let's celebrate our successes while looking forward to those to come. Thank you and enjoy today's event.
Thank you, Commissioner Simpson. We will now hear statements from each of the other 6 ITER members presented according to our custom in alphabetical order. So first, for China, we will hear a statement by President Xi Jinping, the President of the People's Republic of China, read on his behalf by the Minister of Science and Technology, Wang Zhigang.
尊敬的马克龙总统，尊敬的比格总干事，女士们、先生们，我是中国科技部部长王志刚，非常高兴出席伊特计划重大工程安装启动仪式。今天是伊特计划重大工程安装正式启动的重要时刻，也是该计划进程中具有里程碑意义的活动。中国政府对伊特计划高度重视，习近平主席专门发来贺信。下面，我荣幸地向大家宣读中国国家主席习近平致伊特计划重大工程安装启动仪式的贺信。贺信值此国际热核聚变试验堆计划重大工程安装启动之际，我谨表示热烈的祝贺。科学无国界，创新无止境，国际科技合作对于应对人类面临的全球性挑战具有重要意义。国际热核聚变试验堆计划承载着人类和平利用核聚变能的美好愿望，是当今世界最重要的国际科研合作项目之一。国际热核聚变试验堆计划实施以来，中方始终恪守国际承诺。中国企业和科研人员勇挑重担，与国际同行齐心协力，为计划的顺利推进贡献了中国智慧和中国力量。10多年来的积极探索和实践充分证明，开放交流是探索科学前沿的关键路径。当前，全球正面临新冠肺炎疫情带来的严峻挑战，人类比以往任何时候都更需要携手前行，共克时艰。中方愿继续同各方加强科研交流合作，合力突破重大关键科学和技术，推进全球科技创新，为增进各国人民福祉，实现全球可持续发展不断做出新贡献。中华人民共和国主席习近平2020年7月28日宣读完毕。
Thank you so much, Minister Wang, and of course we are deeply honored for having the statement by President Xi. Please now give your attention to Mr. Jawed Ashraf, the Indian ambassador to France and Monaco, who will present a statement from the Prime Minister of the Republic of India, Narendra Modi. Thank you.
It is my honor and privilege to deliver a message on behalf of Prime Minister of India, Shri Narendra Modi. The Director General of ITER, members of ITER, distinguished members of the scientific community of many nations, ladies and gentlemen, Namaskar. My warm greetings to you on this historic occasion. Today we are celebrating the beginning of the ITER assembly activities. It is an important milestone in the progress of the ITER project. We have reached it after an extraordinary journey of many years of commitment, dedication, and hard work by scientists, engineers, and technicians. They have successfully developed and fabricated a wide range of entirely new components that represent design, innovation, and engineering of great complexity and precision. They have done this while adhering to schedules and timelines. Indeed, the ITER organization deserves special appreciation for maintaining its schedule of activities in recent months, despite the disruptions and restrictions of the ongoing pandemic. India is proud to be part of a global enterprise that is at the frontier of science and engineering. Indian scientists have made valuable contribution to the development and fabrication of the cryostat, the cooling system, the cryo distribution system, and several kilometers of cryolines. They remain involved in many other aspects of the project. They have demonstrated India's capabilities for design and manufacture at the most advanced levels. Equally, our institutions, scientists, and engineers have benefited enormously from collaborating with their peers from around the world. ITER is a project of an extraordinary vision and ambition, and of unparalleled scale and complexity. By seeking to simulate the sun's energy production on Earth, it is attempting a task of cosmic proportions. It is as much a testimony of a relentless human pursuit of knowledge as it is of our enduring quest to use science for the welfare of humanity. In this case, as an abundant, clean, and sustainable source of energy. The project is also very special because it involves international collaboration at an unprecedented level. This shared endeavor for our common good is a perfect symbol of the age-old Indian belief, Vasudhaiva Kutumbakam. That means the entire world is one family. Today's event is an important step towards a better tomorrow for mankind. And on behalf of 1.3 billion Indians, I wish the ITER project all success. Thank you.
Thank you, Ambassador Ashraf, and of course, Prime Minister Modi. Now we will give the floor to Hagiyoda Koichi, the Japanese Minister of Education, Culture, Sports, Science, and Technology, who will present a statement by the Prime Minister of Japan, Shinzo Abe.
おはようございます。日本国の文部科学大臣の萩生田光一です。核融合エネルギーの実現に向けた国際プロジェクトであるITER計画における重要な工程である実験炉の組み立て・据え付けを開始するとのこと。1980年代後半から深く関与してきた日本として大変喜ばしくお祝い申し上げます。核融合エネルギーは日本政府が策定した革新的環境イノベーション戦略において脱炭素社会を実現するための革新的技術の一つとして位置づけられており、私としても強力にその推進を図っているところです。折しも全世界で新型コロナウイルスが猛威を振るっている中、ITER計画において日本が製作した世界最大級の超電導コイルがITERサイトに納入されるなど、目標スケジュール通り実験炉の組み立て・据え付けを開始することができました。これは備後機構長がおっしゃるITERミラクルであり、我々の強靭な意志と連携・実行力の賜物と考えます。このように建設・機器製作活動をさまざまな工夫をしながら推進をしていただいているITER機構や各局の研究機関の取り組みを称賛したいと思います。日本においてはITER計画とともに日欧が開始した BA 活動のもと、3月末に核融合実験装置 JT60SA の組み立てが完了したところです。これらの研究開発による成果によって日々の生活をより豊かにすることを祈念しつつ、 ITER 計画の連携をさらに強めていきたいと考えています。ここで安倍首相の祝福メッセージをいただいておりますので、代読をさせていただきます。この度、日欧米ロ中韓印の協力により、フランスにて建設が進んでいるITER計画が実験炉の組み立て据え付け開始という新たなステージに入ることに心から祝意を表します。気候変動という地球規模課題に立ち向かい、脱炭素社会を実現するには革新的なイノベーションの創出が必要です。日本は核融合エネルギーの実現に向け、本計画の黎明期から関与してきました。新型コロナウイルス感染症の世界的な広がりの中にあっても、強固な国際的連帯により、引き続き本計画が力強く進展していくよう祈念いたします。令和2年7月28日、日本国内閣総理大臣、安倍晋三。核融合エネルギーの実用化を実現するまでは、息の長い研究開発が必要です。そのためには、全世界の GDP の約8割を占める世界7極が共同で取り組んでいるITER計画の成功が必要不可欠です。今後のITERの運転開始に向け、より一層各局が力を合わせて取り組んでいくべきです。これからのITERの建設活動が無事に進捗していくこと、また今後の世界7極のITER計画における協力のさらなる進化を祈って、日本国政府からの挨拶とさせていただきます。
Thank you, Minister Hagiuda and Prime Minister Abe. Next, we turn to the Republic of Korea, where we will hear from President Moon Jae-in.
존경하는 마크롱 대통령님, 폰데어 라이엔 EU 집행위원장님, 국제 핵융합실험로 ITER의 베르나 비고 사무총장님, 그리고 회원국 정상과 대표 여러분, 반갑습니다. ITER는 라틴어로 길을 뜻합니다. 우리의 길은 지구의 다른 생명과 함께 공존하는 것입니다. 우리는 지구를 지켜내기 위해 미래 에너지라는 꿈을 꾸었고, 우리의 꿈은 세계가 함께 핵융합 인공태양을 만드는 사상 최대의 국제과학기술 프로젝트 ITER를 낳았습니다. 오늘은 국제 핵융합 실험로 ITER가 장치 조립을 시작하는 기쁜 날입니다. 코로나로 인해 기후환경 보호가 더욱 중요해지는 지금 ITER와 각국 사업단이 인류에게 희망을 주고 있습니다. 우리의 길을 향해 도전하는 전 세계 과학기술자가 있어 든든합니다. 여러분의 노력에 존경과 감사의 말씀을 드립니다. 인공태양은 꿈의 에너지입니다. 바닷물을 활용해 거의 무한정 생산이 가능하고 방사능 위험이나 온실가스 배출도 없는 청정 에너지입니다. 인류가 새로운 과학기술로 개척할 때 늘 그랬듯 ITER 역시 수많은 도전과 시행착오를 겪었습니다. 이를 극복하고 오늘 장치 조립 단계까지 올 수 있었던 것은 ITER를 중심으로 7개 회원국이 함께 지혜를 모았기 때문입니다. 전 세계가 연대하고 협력해 이뤄낸 자랑스러운 성과입니다. 한국의 연구진은 1억 도에 달하는 초고온 플라즈마를 8초간 유지하는 데 성공했습니다. 세계 최장 기록입니다. 초고온을 견뎌내는 진공 용기는 핵융합에 필수적입니다. 한국의 산업체들이 10여 년에 거쳐 이를 개발해냈고 곧 ITER 건설 현장에 도착할 예정입니다. 한국은 방역 물품을 나누며 K방역으로 전 세계와 연대와 협력을 실천했습니다. 이제 과학으로 세계와 함께하고 있어 매우 자랑스럽습니다. 핵심 품목을 만들어 우리의 길에 한 걸음 더 가까이 다가갈 수 있게 되어 한국 국민도 매우 기쁘게 생각하고 있습니다. ITER의 거대 부품들을 조립하는 단계에서 또 다른 도전이 기다리고 있을 것입니다. 코로나로 인한 영향도 경계하고 최소화해야 할 것입니다. 각국이 그동안 제작한 품목을 이제 하나로 완성하듯이 7개국이 하나된 협력으로 새로운 도전을 함께 극복할 것으로 확신합니다. 한국 역시 우수한 과학기술자들이 이트에 더 많이 참여할 수 있도록 지원할 것입니다. 2050년 청정하고 안전한 핵융합 에너지 실현을 위해 국제사회와 함께할 것입니다. 밤하늘의 별은 핵융합으로 빛납니다. 세계가 지혜를 모으면 인공태양이 인류의 미래를 밝게 비출 것입니다. 지구를 지키는 우리의 길을 응원합니다. 꿈을 현실로 만들어가는 여러분을 응원합니다. 감사합니다.
Thank you so much, President Moon. We are deeply honored by your presence and participation. We now turn to Alexei Likachev, the Director General of the State Atomic Energy Corporation, Rosatom, presenting on behalf of Vladimir Putin, the President of the Russian Federation.
Уважаемые дамы и господа, дорогие коллеги, друзья, позвольте огласить приветствие президента Российской Федерации участникам мероприятия по случаю начала сборки и монтажа оборудования установки ITER. Уважаемые дамы и господа, приветствую вас по случаю начала работы по сборке и монтажу оборудования установки международного экспериментального термоядерного реактора ITER. ITER, ставший крупнейшим международным научно-техническим проектом, представляет собой яркий пример эффективного и взаимовыгодного многостороннего сотрудничества. Как известно, Россия является одной из стран-основательниц данной инициативы, призванной внести важный вклад в обеспечение энергетической безопасности человечества и играет активную роль в ее воплощении в жизнь. В основе проекта ITER лежит разработанная в нашей стране концепция установки токамак. Сегодня ITER вступает в решающий этап своей реализации. Несмотря на ограничения, связанные с пандемией коронавирусной инфекции, удалось сохранить бесперебойные темпы работ. Это позволяет рассчитывать, что цели проекта будут достигнуты в намеченные сроки, и уже в обозримой перспективе мы получим уникальный по своей мощности и безопасности источник энергии, эксплуатация которого, несомненно, будет способствовать решению задач устойчивого экономического развития и повышения качества жизни миллионов людей. Хотел бы искренне поблагодарить всех, кто на протяжении многих лет трудится над проектом ITER. Особая признательность президенту Франции Эммануэлю Макрону, как лидеру страны-хозяйки проекта, представляющей площадку для реактора и оказывающей неоценимую помощь в его сооружении. От души желаю вам новых успехов и всего самого доброго. Президент Российской Федерации Владимир Путин. Уважаемые коллеги, позвольте мне также от себя лично поздравить всех участников проекта ITER с началом нового этапа, сборкой и монтажом токамака, который, по сути, является сердцем всего проекта. Это важнейшие события для всего термоядерного сообщества, ну и, конечно, для всей мировой науки. Важно, что, несмотря на ограничения, вызванные эпидемией коронавируса, работы по сборке, по монтажу начинаются в соответствии с графиком. С искренним, глубоким уважением отмечу усилия персонала центральной команды, домашних агентств и лично генерального директора организации ITER господина Бернара Биго. Они сделали все, чтобы многочисленные участники проекта действовали как единая команда. Теперь главная задача для нас всех – обеспечить своевременный монтаж и сборку установки и получить первую плазму к концу 2025 года. Это позволит на деле продемонстрировать согласованность действий всех участников проекта и итоговую эффективность нашего международного сотрудничества. Россия выполняет все обязательства в проекте ITER по внесению натурального и финансового взноса в полном объеме в строгом соответствии с графиком. В том, что сборка реактора началась вовремя, есть большая заслуга России. Верхние патрубки и шинопроводы были своевременно изготовлены и поставлены на площадку ITER. Особо отмечу широту географии работ по ITER в России. В Санкт-Петербурге идут работы по сборке катушки полоидального поля. В Нижнем Новгороде изготовлены и испытаны первые 4 гиротрона. В Москве, Санкт-Петербурге, Казани, Подольске и Новосибирске ведется разработка и изготовление 7 диагностических комплексов, необходимых для обеспечения полномасштабных исследований на стадии первой плазмы и, конечно, в будущих экспериментах. Большинство систем ITER изготавливаются и интегрируются сразу несколькими партнерами из разных стран. Это требует полной слаженности в работе и согласованности действий. Убежден, что на нынешней стадии проекта своевременное выполнение каждым из партнеров своих обязательств по внесению как натурального, так и финансового взноса абсолютно необходимо для нашего общего успеха. Дорогие друзья, проект ITER – это яркий пример открытой научной и технологической кооперации. Поэтому вслед за президентом тоже особо отмечу вклад в проект ITER Франции как страны-хозяйки. Ей удалось создать уникальный климат для совместного эффективного творчества ученых и инженеров, рабочих и специалистов из разных стран. Дух ITER воодушевляет нас всех, кто хоть раз побывал на площадке. Уверен, что нам удастся сохранить его на долгие-долгие годы. Дорогие друзья, уважаемые коллеги, я желаю нам всем дальнейшей успешной работы и удачи. И, конечно, желаю всем здоровья, здоровья и еще раз здоровья.
Thank you, Director General Likachev, and in particular, President Putin. Now for the last stop on our global tour, we will turn to the Secretary of Energy of the United States of America, Dan Bruyette.
Thank you. It's a pleasure and honor to join you for such an important event taking place during extraordinary times. This year has been full of challenges for all of us, so I appreciate the opportunity to be with you in celebrating this significant milestone for the ITER project and the future of energy. The start of machine assembly means that site preparations have concluded and that the project is now receiving components from ITER members around the world. As a consequence, we can now begin to look forward to first plasma and the future beyond. As the United States Secretary of Energy, I'm responsible for the stewardship of 17 national laboratories, which are each spearheading basic and applied research projects in areas ranging from clean energy to materials science to exascale and quantum computing. Projects with incredible impact and world-changing potential. I'm also responsible for our nation's fusion energy efforts, which hold the promise of providing an economical, nearly unlimited, and clean form of energy for future generations. ITER plans to create, hold, and control the hottest material on Earth within some of the coldest materials, and to use that heat to generate electricity. It's an incredible engineering achievement to consider, and first-of-a-kind components that will make up the ITER machine are being fabricated to exacting tolerances around the world and shipped to the for assembly at the site. This new stage has been made possible through decades of collaborative research and engineering in fusion and plasma physics at government laboratories, universities, and companies all around the world. It's a profound story of human endeavor, and the best is yet to come. I'm proud of the significant work at our national laboratories to support this effort, including projects at Oak Ridge, Princeton, and Savannah River. And I'm equally proud of the participation of many U.S. companies. To cite just one example, a company from California is preparing to ship the first of 7 massive superconducting magnets that will comprise the ITER central solenoid. The production of these magnets is the result of close collaboration amongst the United States, Japan, and the ITER organization, and many other components are being fabricated at U.S. companies and laboratories for eventual delivery and incorporation into the reactor. The ITER effort has also helped to renew enthusiasm and optimism about the commercial promise of fusion energy. Several startup companies across North America have been established in recent years to explore potential new concepts for fusion energy, and we've engaged with a number of them in the hope of accelerating progress and reducing costs toward commercial applications. In closing, I'd like to recognize the hard work and the dedication of thousands of ITER staff and contractors at the site, and the many thousands more among the ITER members engaged in fulfilling the promise of fusion energy. While many are responsible for the conception, design, and progress on the project so far, all of the participating nations owe a special debt of gratitude to Director General Bigot for his dedication and expert stewardship of the project over the past 5 years. We in the United States are hopeful about a bright future for fusion energy, and we look forward to the assembly of the reactor and to the promise of what we will learn soon from the testing after first plasma. Good luck to the team in this critical next step of assembly. Thank you again. Let's go to work. Let's change the world.
Thank you, Secretary Bruyette. This brings to a conclusion our global tour. I would ask that all of you would perhaps welcome again back to the podium to conclude our ceremony, Director General Bernard Bigot.
Thanks again, Liban. It has been very rewarding to listen to this declaration by all the 7 ITER members. On behalf of all the ITER community, I would like to express our deepest and most sincere gratitude for this wonderful statement of support from the head of state, ministers, and other officials today, representing all the 7 ITER members. This support from the highest level of ITER members' government is inspiring. To know that we are all working towards the same goal for a future powered by fusion energy will be a constant source of encouragement as we go forward into machine assembly at ITER. I would like to conclude our celebration today by recognizing as well the essential nature of another commitment. I am speaking of the global ITER workforce. As in any other large human enterprise, nothing is possible without highly skilled and motivated staff who execute the work on scope, quality, and schedule. The ITER people are the best asset for ITER's success. Could I ask 3 people to join me on the stage? Laura Bertolo from Europe, the lead contract engineers in the assembling hall. Ashok Sharma from India, tokamak instrumentation engineers. And Li Zhuang from China, an engineer working on tokamak assembly. Thank you very much for joining me. Here in Provence and around the world, more than 10,000 people like them are working together to make ITER a reality. We could not do it without each of you. Those who design and manufacture the component, those who transport them over land and sea to the ITER site, those who install each piece with precision in its proper place, those in support role in finance and legal work, and those who prepare the operation. Unfortunately, we cannot have all of you with us today in person, so I have asked the 3 of you to join me on this stage to represent all the workers on our global One ITER team to say how grateful we are for your hard work, dedication, and professional excellence. I have with me a special crafted disc. This one. This disc is a little bit special. It is made of synthetic sapphire. We refer it as a nanoform disc because it can be inscribed with thousands of pages of material at nanoscale, which can be viewed with a microscope, and it will be last for thousands of years, fully preserved, whatever adverse condition it may face. As a small token of your gratitude to the ITER workforce, and to commemorate our celebration today, we will inscribe your name and photos of such a disc, plus a transcript of the statement given today in our many ITER language with additional photographic image. This disc will be attached to the ITER tokamak building to serve as an enduring record for those who will retrieve it when ITER has achieved its purpose and completed its mission, and possibly to be transferred to the first fusion power plant in the world to deliver electricity on the grid. Thank you very much for your contribution, and so we will provide this inscription. But before leaving, I would like to offer you, each of them, this piece of the superconducting material, the one which will be on the tokamak building with the magnetic coils. Thank you so much. As we conclude our ceremony, we leave you with a musical performance by the ITER Band. You may recognize the piece which we will find appropriate as we pursue the energy of the stars for peaceful purpose. These musicians are ITER scientists, engineers, and other staff. They come from many different backgrounds. For the past few months, during the pandemic, they have been largely isolated from each other. Yet, each one has contributed steadily, some teleworking, some on the ITER work site. Each one has recorded their individual track of music, which we have synchronized to make a single work of harmony. Like the 7 ITER members and ITER organization, we work together in the most integrated way, even if they are distributed all over the world. So thank you so much for all being with us today, and let's listen to the music.